Alright, so the last thing we need from section 4.2 is how to find mean, variance, and standard deviation. And this is not too hard to do. This is actually a case where it's much easier to just use the formulas than it is to plug anything into the calculator. So here's our formulas right here. And let's understand why this is true. So I'll give you a simple example. Suppose that I flip a coin 100 times and I want to find the average number of heads that I can expect. Okay, where obviously I have a 50% chance of getting heads. So if you look at this formula, well, even before using it, you tell me, if you flip a coin 100 times on average, how many heads would you expect? And hopefully you said 50 heads. So if you use this formula right here, let's plug it in. This is saying mu should equal n, the number of trials, which is 100, times p, the chance of success, 100 times 0.5, and you would get 50 heads right there. So that's just an intuitive way of understanding this particular formula. So let's take a look at this problem. It says Pittsburgh, Pennsylvania, 56% of the days are cloudy. It's a pretty cloudy place. Find the mean, variance, and deviation for number of cloudy days in June and interpret the results. Okay, so let's find the mean first. The mean is number of trials. How many trials are there for days? Because we're talking about number of days. How many trials, i.e. how many days are there in June? And the answer is 30. So in this case, n for June would be 30. If we were doing July, then n would be 31. And then p is the chance of success, the chance of successfully picking a day that is cloudy, and that would be 0.56. Now you might say, well, cloudy day is not successful. I prefer sunny days. Remember, it has nothing to do with what we prefer. It's just how we define the experiment. And we define this experiment to mean cloudy day equals success. So you plug that in and you would expect about 16.8 days to be cloudy. That makes sense because 56 is a little bit more than half, and a little bit more than half of 30 days would be 16.8. Alright, then we want to find variation and or variance, I should say, and deviation, standard deviation. So this sigma squared is going to be 30 times 0.56 times q, and q is just this number subtracted from 1. Okay, the chance of failure. So this number right here, we already found that out. That's 16.8. That's what we found right here. So 16.8 times 0.44, when you put that in the calculator, you end up getting 7.39, roughly 7.392. So there's your variation. How do you find the deviation? If you know the variance, you just take the square root of that number. Okay, so when you take the square root of that number right there, that means you would get a deviation of 2.72 days. So the average number of cloudy days in June is 16.8, give or take 2.7 days either way.